Hello everyone, so now we will do some questions of the exercise 8.1 of our chapter infinite series, right? So first we have done the sequence portion, so let's see what kind of question we have here. So first we have each of the exercise 1 to 6 give the formula for nth term, gives the formula for the nth term an of a sequence, find the values of a1, a2 and an. Okay, so an is given to you, so it's very easy to do such questions. So they are asking you to calculate a1, a2, a3, a4. So I have told you earlier as well. So what you need to do, in place of n you have 1 here, just put 1, so it will have 0, right? And now you have, in place of n you have 2. Okay, so just put 2 here, so you will have minus 1 upon 4. So now again in place of n we have 3, so just put n equals to 3, right? So minus 2 upon 9. Now in place of n we have 4 here, so just put n equals to 4. Then you will have 1 minus 4 upon 4 square, that means minus 3 upon 16. So this is how you will handle these questions, right? So similarly, if I choose this a fourth question, that means an equals to 2 plus minus 1 raised to power n. So if a, then a1 put n equals to 1, so 2 plus minus 1 raised to power 1, right? So it will be minus 1, sorry 1. Then put an equals to 2, you will have minus 1 raised to power 2, that means 2 plus 1, that means 3, right? And similarly a3, 2 plus 1 raised to power 3, 2 minus 1, that means 1 again, right? So similarly you can do the rest of the questions, right? So next we have question number 7. So here the sequence is given in the form of recurrence relation. So they are asking you to write the first 10 terms, that means a1, a2 up to so on to a10 they are asking you to write. So they are very easy to write, right? Why? So a1 is given, right? A1 is already given, and for next terms they have given you the formula. So we have done this in the theory section. That means for to calculate a2 I have to put n equals to 1 in this formula, right? So I'll have a2 equals to a1, because in place of n I'm putting 1 here. So I'll have this. So a1, the value of a1 is known, that is 1 plus 1 by 2, that means 3 by 2, right? So now I have to calculate a3. So to calculate a3 I have to put what in place of n? I have to put n equals to 2. Then it will become 2 plus 1 3 and equals to a2 plus 1 upon 2 square, and a2 is known, that is 3 by 2 plus 1 by 4, right? So again you can calculate it, 4, this is 5, right? So this is how you will go for these questions. Okay, so here you will have 6 plus 1, that means 7 by 4, right? So next is a4. So what value you have to put here in place of n? 3. So if you put n equals to 3, you will have this equals to a4, n equals to a3 plus 2 raised to power 3, right? Again a3, the value of a3 is known, so now you can calculate this. So 8 will be the LCM, then again 14 plus 1, that means 15 by 8. And similarly you can go for a5. Okay, so in place of n you have to put 4 here. Then for a6 you have to put n equals to 5, and so on, right? So similarly you can calculate the next remaining terms, right? So similarly you have to do the rest of the question. It's quite same for all of them, right? So let's choose this question 11th. So a1 a2 is given here, right? So a1 a2 is given, so a1 equals to a2 equals to 1, it is given to you, right? And for the next terms they have given the formula an plus 2 equals to an plus 2 equals to an plus 1 plus an. So I have to calculate a3 by using this formula. So tell me what value I should put here in place of n? 1. Okay, so if I put n equals to 1, I'll have a1 plus 2 equals to a1 plus 1 plus a1, that means a3 equals to a2 plus a1, and a2 and a1 are known, so both are 1 1, so I'll have 2, right? So similarly to calculate a4, what I need to do, I have to put n equals to 2, right? So I'll have 2 plus 2 4, so 2 plus 1 plus a2, that means a3 plus a2. A3 is, I have just calculated, that is 2, and a2 is given earlier, so that means 3. So this will be the value of a4, right? So similarly you can go for, you put n equal to 3, you will get a5, you will n put equal to 4, you will get a6, right, and so on. Next you can calculate further in the rest of the terms. So this is how you will handle these questions. Okay, so next the other type of the sequence they have given. So you have to find the nth term for the sequence, right? So this is what is given here. So earlier the nth term was given, they were asking you to write the terms of the sequence, like first 4 or first 10 or first 12 terms, right? So here they have given the terms of the sequences. So now they are asking you to find a such formula, that is nth term of the sequence. So first is they have given the sequence 1 minus 1 1 minus 1. So that means we have alternation in sign. So whenever you have alternation, so you must multiply by this factor, either this. So see, if I put n equal to 1, I'll get minus 1. If I n equal to put 2, then I get 1, then again minus 1, and n equal to 3. At even I'll get plus 1, and at odd I'll get minus 1, right? At odd places, right? So this is how we will proceed. But sequence is given in another way, that means 1 minus 1. So what I need to do, I just have to add 1 here. Now if I put n equal to 1, this term will become even, and when I put even, it will become odd. So now I'll have my sequence that is given in the question, right? So whenever you have alternation, you must multiply by minus 1 raised to power n factor. So here it depends that if your sequence is starting from minus sign, then it will work, right? And if it is starting from positive sign, you have just add 1 here. So you can also write it minus 1 raised to power 2n minus 1, right? So again, if I put 1 here, I'll get this sequence. So both are the same things. So you can write in whatever way you want. You can also write an equals to cos n pi. Why? When you put, what sequence you will get? Cos pi, cos 2 pi, cos 3 pi, cos 4 pi, and so on. And cos pi we know minus 1, cos 2 pi is 1, again this 1 and minus 1, right? Like this. So this is also work as a alternation in sign. It also brings the alternation in the signs. So whatever way you can write. So this is also a right way to write our sequences that is given the question. And if I write this as an equal to minus cos n pi, then this will also work. So both will be correct, right? So you can do like this. So whenever you have alternation, must keep this thing in mind, that you have this factor there, minus 1 raised to power. That now the power will, that depends that whether you have a minus sign in the first place or in the second, right? Accordingly you can change the n, and either you will put n or n plus 1, right? Or 2n minus 1, 2n plus 1 accordingly. So that is given in the second question, right? So now we have the 15th question, 1 minus 4 9. So again you have alternation in sign, that means minus 1 raised to power n factor will be there. So as we have positive term first, I'll put n minus 1 raised to power n plus 1, and rest is 1 square, 2 square, 3 square. So it will be n square, n the term. So this will be an, right? Because all these terms are the square of the integers, right? So 1 square, it will be 2 square, it will be 3 square, it will be 4 square, it will be 5 square. So n term will be n square, right? So this is what I have written. And for alternation, I have just multiplied this thing by this factor that I have told you earlier, that minus 1 raised to power n plus 1, right? So similarly you can do for 16th, right? So this is how you will handle these questions. So thank you so much. If you find any doubt, you can ask me in the comment section. Thank you.